And so for me, somebody might have, I don't think that's a great way to do it because it's just not following that high in the air. I was thinking the graph would go more like this. I don't know. Something maybe like that is probably what I would do. Because, this one's about that far away. And we're not exactly covering why, like what these residuals have to do with the graph. So basically, you want stuff represented like all those heights above and all the heights below. Or sorry, there was a fourth height up there. Those four heights above to equal roughly those two heights below. That's not exactly how regression works, but it's similar to that. So, something like that that's the best I could do right now. What I'm trying to say. So it says write an approximate equation for the line of best fit. Now we drew one, but have we written one? And so from here, when we write an equation, we need a point and a slope. I'll read the word. We need a point and a slope. And so the slope, remember, that's calculated by rise over run. So, excuse me, if slope is rise over run, I want to, if I have any points going through, you can see I've got a point going through right there and a point going through right here. And so I'm going to do my best to count, or I could calculate the rise over run for finding the slope. So those 2 points, it looks like that's probably 22, 0, maybe. Somebody could argue maybe something less, but let's just go with that. And then that other star looks like that's maybe 53, 8. Again, we're just guesstimating here. It's not going to be. If it wanted a perfect answer, it would have given you a point on the line. And so the slope, remember, that comes from subtracting those y values, the y2 minus y1, all over the x2 minus x1, 53. So you could have had 0 minus 8. You would have just had to do 22 minus 53. From there, we've got 8 over whatever that subtraction is. Is that 31? And then dividing those guys. I could have left it as 8 over 31, which I might. We'll convert it to decimal and then see what we would rather have. So that's my slope. And then the point, we have, we can use either of those points there. So we've got y equals, now we've got, I'm going to leave it as 8 over 31, and hopefully you'll see why in just a second. 8 over 31x plus b. And I need to use that point to solve for that b value. So remember, I always told you guys the easier way is to use anything with a 0. When people see that, they probably wouldn't. My mind actually did for a second. I jumped to like, oh, great, I have the y-intercept. But again, the y-intercept is only when the x value is 0. So I'm going to take that 22 and plug it in for the x and the 0 and for the y. So that will give me 0 equals 8 over 31 times 22 plus b. Multiplying 8 over 31. I should just made it a decimal because this is going to be annoying. 8 times 22 is 176. So I'm going to continue the work over here. So we've got 0 equals 176 over 31 plus b. So that decimal is 5.677. And moving it to the other side, we've got negative 5.677 equals b. Okay, so our actual equation, if we just use the decimals to make our lives a little bit easier, it's going to be 0.258 x minus 5.677. Kind of took us a second to get there, but hopefully that's making a little bit of sense. The reason why I left this as a fraction is because I wanted you to see for every 8 days missed, their age goes up by 31. So Yeah, so again, since slope is rise over run, for every 8 days that they miss, it would increase by about 31 years. Just that's why I would left it as that. When you see it as just 0.258, that would be for every 0.25 days missed, the age goes up by 1. So that's not very like helpful. I don't know. Like I feel like it's easier to interpret the slope sometimes when it's as a whole number like that. So last question, then we'll take our break. The number of days missed by a 56-year-old employee. So since that age is the X value, it's telling you to plug in 56 for X. Okay. So that will give us a situation like this. And this time I will do the skeleton step because I've got enough room. The skeleton step was born out of working with the quadratic formula, and there was just so many places for students to plug in numbers. And so when you only have one number to plug in, it seems a little bit like unnecessary, but hopefully it's making sense to demonstrate some substitution there. When I multiply 56 by the 0.258, I get 14.448, and I take away 5.677. To get a final answer of the number of days missed to be 8.771 days if they're 56 years old.